Have you ever wondered how your favorite streaming service can handle millions of people watching a live finale all at once without even a hiccup? Well, the secret is this powerful but pretty much invisible technology called load balancing. Today, we're going to pull back the curtain on this unsung hero of the internet. But first, let's talk about a frustration I'm sure we've all felt. You're trying to buy concert tickets the second they drop, or you're refreshing a news site during some huge breaking story. And then, poof, the site is just down. How can some of the biggest websites on the planet just vanish like that? The answer is actually surprisingly simple. It's a digital traffic jam. I want you to imagine a single-lane road that leads to a giant stadium. If every single person tries to drive in at the exact same time, that road just becomes a parking lot, right? Gridlock. That is exactly what happens to a web server. When millions of requests all flood in at once, the server just grinds to a halt and the website crashes. So how do you solve a traffic jam that massive? You don't just make the road wider, you build a bunch of new roads, and you create a system to direct all that traffic intelligently. And in the digital world, that system is called load balancing. And that, my friends, is the hero of our story. At its core, load balancing does exactly what its name suggests. Think of it like a really smart traffic cop for the internet. Instead of letting all that traffic pile up and crash into a single server, the load balancer directs requests to a whole team of servers. This makes sure that no single one gets totally overwhelmed. This image of a traffic roundabout is a perfect way to visualize it. Just like a roundabout keeps cars flowing smoothly by giving them different exits, a load balancer keeps all that data flowing by sending it to different servers. It's all about preventing that digital gridlock. And the benefits here are just massive. And it's not just about speed. It's about making the internet way more reliable. So if one server goes down, the load balancer just instantly, and I mean instantly, reroutes traffic to another healthy server. You, the user, never even have a clue there was a problem. And when a website gets that huge sudden surge in traffic, new servers can be spun up in an instant to handle the load. So yeah, next time your favorite show doesn't buffer during the season finale, you can thank a load balancer working silently in the background. Now, that ability to add new servers on the fly brings us to a really fundamental question in system design. Is it better to have one giant, super powerful server or a whole team of smaller, more nimble ones? This is the classic debate between scaling up and scaling out. So scaling up is kind of like trying to put a giant rocket engine in your car. Sure, it's going to be incredibly fast, but if that one engine breaks down, well, you're stranded. Scaling out, on the other hand, is like having a whole fleet of cars. If one gets a flat tire, you just hop at another one. No problem. The load balancer is the dispatcher that tells you which car to take. Okay, so we know the load balancer is a smart traffic director, but how does it actually make its decisions? How does it know which server is the best one to handle your specific request at that exact moment? Let's take a look under the hood. The secret sauce here is algorithms. These are basically the load balancer's playbook. They're a set of rules that tell it how to distribute all the traffic. And just like in sports, there are different plays for different situations. The simplest play in the book is called round robin. It's like dealing a deck of cards. The first request goes to server 1, the second to server 2, the third to server 3, and you just keep going down the line. It's fair, sure, but it's not very smart. It doesn't care if server 1 is already buried in work while server 3 is just sitting there twiddling its thumbs. A much smarter approach is the least connections method. Now, instead of just blindly dealing the cards, this algorithm actually looks at what's going on. It sends the new request to whichever server has the fewest active connections at that moment. It's like giving the work to the person who has the least to do. Makes sense, right? Okay, now things get even more interesting. You see, not all load balancers are created equal. Some are like traffic cops who can only see the make and model of a car, while others can see who's driving, where they're going, and what's in the trunk. It all depends on which layer of the internet they're working on. And that brings us to the two main types of these digital traffic cops, Layer 4 and Layer 7. A Layer 4 load balancer is like that first cop. It only sees basic network info, like an IP address. It makes really fast, simple decisions. But a Layer 7 load balancer, that's our super cop with X-ray vision. It can see everything inside the request, like the specific URL you want to go to. This allows for much, much smarter decisions, like sending all video requests to servers that are optimized just for streaming. But what if a server suddenly gets sick? A load balancer has to know which servers are healthy and which ones are on life support. It does this with a series of health checks, kind of like a doctor making the rounds. Active checks are like asking the server, hey, you feeling okay? Passive checks are more like monitoring for symptoms, looking for server errors, those 5xx codes, which are basically a cry for help. If enough symptoms pop up, that server gets taken out of rotation to go recover. All right, now that we've gone through the technical stuff, let's talk about where you'll find load balancing in the real world. You might be surprised to find out that you probably use it every single day without even knowing it. The answer is just about everywhere. Every time you go to Amazon or Google, log into your work computer, connect to a corporate VPN to work from home, or even just use your mobile banking app, you are almost certainly interacting with a load balancer. It's the invisible engine that keeps our digital world running. And this slide right here shows a perfect real-world example of the kind of decisions engineers have to make. This developer is asking if they can swap one type of load balancer for another. And the answer to that question isn't just technical trivia. It can have a huge impact on the performance, cost, and reliability of their entire system. And when it comes to choosing a load balancer, engineers have a lot of options. They can buy a dedicated hardware appliance. That's like getting a top-of-the-line custom-built race car. They could use flexible software. That's more like building your own car from a kit. Or they can just use a cloud service, which is basically like renting a car whenever you need one. Each choice has its own pros and cons, and the right one depends entirely on the job. So as we've seen, load balancing is really the secret sauce that makes the modern internet possible. It's the invisible technology that keeps our favorite websites and apps running so smoothly, and it's the reason we can stream movies, shop online, and connect with people all over the globe without a second thought. It really is the internet's unsung hero. You know, load balancing is kind of like the foundation of a skyscraper. You never see it, but you can be absolutely sure that without it, the whole building would come crashing down. It's that invisible force that turns a fragile collection of individual servers into this powerful, resilient system that can handle even the biggest digital storms. And that really brings us to the big question for the future. As artificial intelligence and the Internet of Things create this absolute tidal wave of new data, will our current load balancing strategies be enough to keep the internet from drowning? The digital traffic jams of tomorrow are going to be unlike anything we've ever seen, and it's going to take a whole new level of intelligence to keep all that data flowing.